no, that's fine. So then they emailed me yesterday afternoon saying, okay, so we talked to 10 different people who want to help out with this, and they're going to bring their independent study forms to you. And I was like, huh.
Wow.
I don't know. I don't know if I was like, this really wasn't my intention, but.
Well, we can talk about that after the
Yeah.
thing. Oops, this is not plugged in for some reason. I'll fix that. Okay, I think it's ready.
Okay.
I think I'm not sure. Okay. There we go. Now it's working. Cool.
Okay.
I brought your browser up too.
Okay, great.
Do you need access to that code, or did you put it somewhere you can get it?
Yeah, I put it somewhere where I can get to it. Well, welcome to the virtual office hours, the last one probably for this MOOC. And we're going to be walking through the solutions from 3A and 3B, at least the key parts, because a lot of these solutions may vary from person to person based on how they implemented their UI and other aspects. But we're going to focus on some of the core networking and pieces with retrofit and the OAuth that people are going to be needing when they're looking at how they do the grading. So I'm going to go ahead and set up screen sharing here and pull up the code from the assignment. So this is a solution that one of our TAs, Chinmaya, he took the sequence last year and did a really fantastic job and helped us TA this year. And he put together this solution to 3A and 3B, and we're going to walk through some of the things that he did. So one of the first things that we need to have for this assignment is a way to log in. And what we've got here is a login activity that, and we'll talk a little bit about the security around this. It has a login GUI with username and password, and then it has an on-login method that gets called when somebody goes to log in. Now, the assumption that Chinmaya has made is that he's dealing with a threat model where if somebody steals your device, they will potentially have access to your username and password because they can physically have the device, plug it in, and go access your username or your password. But his threat model is sort of assuming that it will store everything privately and keep the credentials away from other apps. So he's basically accepting that it's possible that if somebody gets physical access that they will be able to steal your username and password. But as long as the device is in the hands of the correct holder, then no malicious apps or anything else are going to be able to break in and get access to the username and password. So what he's doing, the way that he's doing this, is he's using shared preferences to store the user ID and the password. So on the login screen, when you provide this information, and then you hit the login button, he's essentially just opening shared preferences, and in the private shared preferences for this application, he's storing the user ID and password, and then starting up the video list. And I'll talk in a minute about how he's using this username and password to do the OAuth part of this solution. Now, he's got roughly the same login activity for both assignment versions A and B, and you could do this for both A and B. And so for the pieces that are common across the solutions, I'm just going to show them once. But for the pieces that are different, I'll show the solution for 3A and also show this solution for 3B. So for both of them, he's going to have a login screen where he saves the username and password and shared preferences. Now, we're going to walk in and dive into the solution for 3A now and get a little bit more specific on what he's doing with this username and password in a second. So one of the most fundamental things that you have to do in this assignment is be able to show a list of videos. Chinmaya built this solution off of the previous solution from the prior MOOC, since this was 3A, where videos were being downloaded and stored in a local content provider to essentially cache them on the device, and then displaying the videos in the list is actually pulling them from the local content provider. So the way this works is he's created a let me make sure I'm looking at the right version here. Well, wait, hold on for a second. Let me pull this up. There we go. Pull up the right version here. Make sure this is the same one. It is. He is creating a typical list view, and what he's doing is he's using the Android loader framework to load data into the list view from his content provider. And much of this would have been gone over in the prior MOOC and some of the MOOCs previous to that. But he's basically using a content provider to load all of the data into his list view. Now, one of the things that he's doing is when we first create this list view, is he has a call to go and get the video list. And let's go and look at what this actually does. So the get video list, which is a little farther down here, basically creates an async task and executes it. And the reason this is being run in an async task is because it's going to go and have network activity, so we don't want to run that on the main thread. And what his async task does is it uses this video data mediator class to get and save the video metadata from the server into the content provider. And then when he's done, he has this method to go and show the results. Now, show the results is actually a little bit of a trick here, because all it's doing is just displaying a different toast depending on if it successfully got the video data or not. The real bulk of this is this video data mediator essentially goes and fetches all of the data from the server, and I'll dive into this class in a second, and then stores it in the content provider. And because he's using a content provider in the loader framework from Android, when he updates that content provider by adding new videos to it, this list view automatically gets updated by Android with the new data that's been put into the content provider. So he's not directly updating this list view. Instead, he's going and fetching data from the network, putting it in the content provider, and then the loader framework for Android is doing the updates to this list view to display the list of videos. So let's dive into this video data mediator class, which is really the meat of the solution. So if you did the previous assignment from the past MOOC, the video data mediator really has most of the changes to your assignment that you would be implementing. So let's go take a look at this class. So the video data mediator, I'll just take a brief overview first and look at some of the methods. So as you can see, there's a bunch of methods that you would expect to see for the part of the code that's interacting with the server. So we can upload a video, we have a method for that. We have download video as a method. We have get and save video metadata, and rate video, get rating, and get video by ID. So this is essentially the client side that's going to go and provide the interface to the server and all of the matching methods on the server to go and create videos, download them, rate them, and add the binary data for them. Now, one of the things we can see up top is that he's creating a video service proxy, which we'll look at in a second, which is essentially going to be a retrofit system for accessing the server and getting the video metadata and other information back. So let's take a look down here and see how he's creating this video service proxy. So the first thing he does when he creates one of these video mediators is he initializes the video service. And the idea behind this is the video service is going to be the connection using retrofit, the configuration of that connection using retrofit to the server, so that the video data mediator can make network calls to the server to get the video metadata. So he's going and he's extracting the username and password that were previously saved in shared preferences in the login activity, and then he's constructing a video service proxy using the secured REST builder that we provided for you in the assignment code. And so what he's doing is he's just setting the username and the password for the secured REST builder. He's also setting some information that's needed about the URL of the server and the ID of the client that's going to be accessing things, and then he's using the unsafe HTTPS client to go and access the server, because we're not using signed certificates, so he has to use that unsafe version. So he goes and creates a secured REST builder, which is automatically going to handle all of the OAuth steps that need to happen when you make a call. Then once he's done that, if we go and look, for example, at the methods for getting the video metadata, all he's doing is calling the standard retrofit methods that you would expect. So in this example, he's calling the method that's going to send an HTTP request to get the list of videos from the server, and then automatically unmarshal the JSON into a list of video objects. So this is the same retrofit code that we saw before. There's nothing new that's being provided or done directly in his code from an OAuth perspective, other than providing the username and password. And then in his case, he goes and fetches the list of videos. He goes and inserts them into the content provider. For example, right here, this cache is the content provider that he's using locally on the device, and he goes and updates some various things. But really, the bulk of this is just he's still using retrofit just like he was before. So the big difference from his previous code and this code, if you had to look at the two side by side, the main difference between them is now he has a login activity, and when he's initializing his retrofit code, rather than directly using the normal retrofit code, he's using the secured REST builder that we provided with the username and password that we provided. Now, if we dive in a little bit to the, if we can, here we go. I have to find the, so if we go into the secured REST builder class, basically what this does is it looks at and tracks whether or not the user has logged in or not. So whenever the way this works is whenever the retrofit goes to make a call, so for example, when he's calling get video list, behind the scenes, retrofit is going to call this intercept method, and it's essentially going to check, have we logged in yet or not? If we have, then everything just proceeds normally. And what we do is we just add the OAuth token that we previously obtained. So what this interceptor is doing is essentially automatically inserting the OAuth tokens or obtaining them if needed before making the calls that retrofit would normally make. So when we're calling the get video list, we're going to be sending a request to some video path in the server, and the server is going to be expecting us to have an OAuth token in our request. So what this intercept method is doing, and again, all of this code was provided for you, is essentially adding an authorization header with the appropriate OAuth token to get access if you've already logged in. If you haven't logged in, then what this client is doing is basically going and essentially making the URL, the request to the URL to obtain an OAuth token. So it's creating a URL encoded post that it can use to get the token. It's doing some of the basic authentication that it needs to do, and then it's sending this request off to the server in order to get back finally the access token from the server that was OAuth based that you requested. So this code, again, it was all provided for you, but this shows you an example of how you can, use retrofit and bolt on top of it OAuth by saying, for example, if I'm logged in, then just add the OAuth token. If I'm not logged in, then this is just showing a request to the endpoint in Spring to get an OAuth token, and then add it to the request that you're sending out through retrofit. And again, this is the same for both versions of the assignment. We provided the secured REST builder for both versions of the assignment, and for each one of them, you didn't have to look at the details, but if you want to, it's here. And the key thing was just you're going to replace your original, retrofit builder with this version that takes a username, a password, and a client ID in, so that you could go ahead and do the OAuth authentication. And we had an example up here of how to use it. Now, if we go back, we can look at a little more detail of the video data mediator and some of the things he's doing. That was essentially all of the OAuth. All of the OAuth comes down to storing the username and password from the login, and then using this new version of the builder. Everything else gets handled for you in the OAuth authentication with the code that we provided. Now, his video data mediator, essentially its job is when it's asked to either go and send data to the server or to download data and provide it to the content provider. So most of this is going to look the same as in the solution that was presented to the prior MOOCs assignment. So we have the ability to upload video to the server. And again, all of this is just using the video service proxy and calling the various retrofit annotated methods to upload or download videos. And this, this code should look roughly the same as all the tests that you've seen on the server side. We have download video. Again, we're using the retrofit code to go and download the data from the server and then just store it. And again, all of the OAuth is handled behind the scenes by that secured REST builder. And then we have get and save video metadata, where he's going and getting the data from the server and then storing it in a content provider, which he's calling this video cache. So he's downloading all the videos and then inserting all of those videos into the content provider. And then finally, we have ratings, again, using the retrofit code to go and update the ratings of videos or get the ratings of videos. Let's take a look at the code here for the video service. So if we go and look at the video service proxy, again, this is just a retrofit interface where we are pointing the various calls that are annotated at the video service on the server using retrofit annotation. So we've got getting a list of videos, getting a specific video, getting the ratings of a video, updating the rating of a video, getting the rating of a specific video. All of these things are provided here, and these are just standard Java interfaces annotated with, or a standard Java interface annotated with the retrofit information. Again, there's nothing OAuth in here. All the OAuth stuff is done by the secured REST builder once it's got a username and password. So if we go back to the views, the list videos activity, as we saw, is essentially just grabbing the information from the content provider and displaying it. We have a video details activity that he's created. It does some very similar things. It goes and accesses, he's using fragments, and it goes and uses the video mediator to go and download video data when it needs to, or load it. And so, for example, if you want to get the rating for a particular video, he's using the video data mediator to get the ratings. Again, when you want to set the rating, any of these types of things, he's using the video data mediator. So again, all of this code, all these calls, his UI is just connected to this video data mediator, which is providing the calls back and forth to the server. So the 3A solution is based on very tightly the previous solution. Really, the big change, and there's only one major change, and that's that you're using the secured REST builder to do the OAuth automatically for you in the background, and you're having to provide a login screen to make that happen. So let's take a look at 3B, which doesn't use a content provider in the solution that we're going to show. So again, we have a login activity. It looks essentially the same as the previous one. We just get a username and password, and we're storing it in shared preferences. Now we have a list videos activity, and this one works slightly different than the previous one. This one actually does not use a content provider, and instead it loads data using the video data mediator and then directly stores it into a video adapter which displays it. So it's not using a content provider. So again, we have when we start up, we have this get video list method. So it's very similar to the previous one. We also, again, we're using the secured REST builder with the information from the shared preferences. So we're initializing that essentially exactly the same. And then in the get video list method, we're doing things slightly differently than before. So before, what we were doing is we were going and using the video data mediator to go and fetch all of that data from the server and then store it in a content provider. Here we've changed our video data mediator, and what we're doing is essentially directly capturing, using the retrofit interface to directly pull the data from the server and then return it as a list of videos. So because we're doing network communication, we're creating an async task. And then in that async task, in the background part, we're going and using retrofit to call and fetch the list of videos. And then when the list of videos is fetched, it's being passed to the onPostExecute method, and it's being shown through this show get videos result. And basically what show does is it takes the list adapter that's backing up this list view, and it adds all of the videos to it so that they can be displayed on screen. Now, if we go and look and dive into this mVideo service proxy, which let's just go ahead and up here where we'll just show you where it's defined up here. It's the video service proxy. So let's go ahead and take a look at that. And what we'll see is that it's essentially the same as the one that we saw previously, just some slight tweaks because it has less to do, and it's dealing with liking and unliking. So we again have a retrofit annotated interface, and we are getting the list of videos, we're getting specific videos, adding videos, and we're liking and unliking videos. And again, all of this is just done through providing these methods and annotating them with the correct retrofit annotations so that we send HTTP requests to our server to access these endpoints. And then if we go and take a look at where we use this again, if we go and look at our views, for example, when we're listing views, or listing videos, sorry, we can go and see that we're just setting up the secured version, which we just went over for the previous solution, exactly the same. We're providing the username, password, and other information. And then the secured REST builder is automatically going to take care of OAuth for us. We're not having to do it each time. It's just going off and doing it. And again, we're using shared preferences to store the password and other information about the client. So this is securing it from other apps from seeing it, but if somebody got physical access to the device, this would not secure it. So if you hand somebody your device, they could get access to your username and password. And for the other aspects of this, it's essentially all of them are using, again, the retrofit calls. The UI and all of those pieces may be different depending on each person's version of how they do this. But the key thing that you want to look for when you're grading this is, do they have a login screen? Are they saving the username and password in some reasonable place like shared preferences privately? Are they then passing it into a secured REST builder, because they should have to be using a secured REST builder to do this? Now, they may have created their own version of something like the secured REST builder, and that's fine too. But you want to make sure that they are using a server that's has OAuth enabled, and that they do have something that looks like they're accessing the token endpoints, similar to how the secured REST builder did it, if they're not using the secured REST builder. If they're using the secured REST builder and they're passing a username and password and this other information, then that's essentially all they had to do to make the OAuth part of this assignment work. Okay, I'm going to go back and take some questions now. And got a bunch of questions queued up, so I'll go ahead and get started. All right. Is the procedure for registering for the capstone different from that of other MOOCs in the specialization? Yes, it is.
They have to be invited when they're eligible.
Yeah, so once you are determined eligible by Coursera, you will get an invite email, and that will have directions on how you go and actually sign up for the capstone. So as soon as this class closes, we're going to very quickly get the grades out, and Coursera should immediately see that you're eligible and send you the appropriate invite email. So if you get your grade for this and you don't very shortly after get invited to the capstone, please reach out to Coursera and let them know. They should be getting those emails out quickly. Okay, here's a great question. So you said that if somebody gets physical access to the phone, they can get the sensible data or the login data from shared preferences. What would be a more secure solution for that? So Android has a key store, and so a more secure solution for this would be to actually encrypt the password and username and other information before it's stored. So you could store it in shared preferences encrypted or somewhere else encrypted, and then store the encryption key into Android's key store. And that way, if you use the key store API, Android protects its keys and has various mechanisms that were beyond the scope of this MOOC for protecting those keys and trying to make it harder with physical access to get access to them. It's still not impossible, and there's all kinds of challenges related to, passwords and how strong of a password you're going to have on mobile for the key store. But in general, that's the way that you would do it in a more secure manner than this, would be to encrypt it, both the username, password, and anything else sensitive before you store it, and then take the encryption key and store it in Android's key store. This one is for Doug. Doug, the question is, what is going to be the new material in programming mobile services for Android handheld systems content?
It'll basically be about content providers, and I've posted a summary of the syllabus on the web.
Okay.
I'll repost that.
So the basic focus of the MOOC is on content providers, and Doug has posted a syllabus basically it's posted a syllabus for it on the website for it. So if you go and take a look at that, it'll have more detail on what all it's going to cover. Okay. Is a solution not having shared preferences valid? Yes. So if they have a solution that saves things, let's say privately in a file in the private data for the app, that's fine. If they store it anywhere they store that data privately and load it, That's perfectly fine. It's also perfectly fine if they don't ever store the username and password on disk. So if they just pass it around, let's say through intents, for example, when they need to use it to create the secured REST builder, that's a perfectly fine solution too. And there wasn't an expectation that you would share it with shared preferences. So the key is that they're using the secured REST builder and that they are initializing the secured REST builder with username and password. If they don't store it, that's perfectly fine. If they do store it somewhere else, it's fine as long as they store it somewhere private. So you want to make sure that they are using an actual private location that is private on all versions of Android. So the private storage for the app, for example, with the appropriate permissions on the files. Should students on signature track score 70% and above to qualify for capstone, or can they qualify with a pass score? I believe they need to score 70% and above, but I'll confirm this with Doug. That is correct. You need to score 70% or above in order to qualify.
All those details are on the website.
Yeah, and again, all of these details are on the website, so you should be able to find them in the FAQ and other locations. In my solution for assignment 3A, the client ID was hard-coded. In a real solution, how do we get the client ID? It just depends. It really depends on the application and how you're building it. For example, you may always have this. All your clients may always have the same ID. That you may not differentiate them. You may have something where clients have to go and register on your website to create a client ID that they're going to use uniquely. It just depends on the application. There's a variety of ways that could be done. I'd be interested to know some stats about this MOOC compared with the others in the specialization. How many people participated and how many started the series? I don't have.
Well, they've all been about 20,000.
Okay, so all of the MOOCs have been about 20,000 people, although I think it's not really an apples to apples comparison. Doug, don't you agree? Because there's some of the first classes running more often. And
No, I meant all of our classes, all the ones that Vanderbilt has taught.
Oh, okay, yeah. All of the classes this time have been about 20,000. And how many people are going to be all the way through to the capstone? Unsure, but I believe last year it was about 3,000 that made it all the way through.
About 1,200.
1,200 made it to the capstone. And participated with the capstone last year. Okay, let's see. My solution asks for login every time it starts, and that's totally fine. If somebody has a solution that asks for login every time it starts, they should not lose points for that. That is a fully valid solution, and that's okay. If they don't want to store it, that's perfectly fine. And I think actually in the description, it made it explicit that you don't have to store it, that you can ask for it every time. We didn't want to, you could have stored it, but if you didn't, that's a full solution. That's perfectly valid. One problem I had was when a user logs in and rates a video, everything is fine. But when a second user logs in, the same token is used on the server, and it's if the first user is the one posting a rating. You should get a different token for each user. So if you logged in with 2 different users, they should have 2 different identities on the server and therefore end up with separate ratings for it. So that sounds like either you were reusing the same username and password when you were doing the login, or something else was going on the server. Although my first intuition for this is probably that you were logging in with the same username and password twice on each client, and that's why they would both end up being the same user on the server side, because it's still the same user account. Okay, there's also a question about grading, but we're not going to answer those online. That would be a better thing to go and post on the forums and have available there. In the fourth virtual office hours, you mentioned that we shouldn't calculate the average rating by searching through all the records. So what would be the best way to do it in a real-world application? So the answer to this is it's not necessarily that you shouldn't do it this way. It just depends on your assumptions about the assignment. So if your application has lots and lots of ratings per video, then if each time you had somebody ask for a rating of a video, you went and searched, let's say, 100,000 ratings, that would be really expensive, especially for something that gets calculated. Let's say, once you've calculated it once, it may not change substantially over time. So there's a lot of different ways you could do it depending on your assumptions and what you're trying to do. There are things like Sharded Counters. If you took the previous MOOC and went through those videos, where you can try to have a more efficient way of measuring things like counts. You could also have a batch process that runs in the background. So your average rating is only accurate up to a certain point in time. So for example, a simple way to do this would be you have everybody insert their individual ratings, and then at 11:59 p.m. A batch process runs and it calculates the new rating that's going to be used the next day. Which, if you have a whole lot of ratings, and let's say there's not that many coming in that quickly, it may not, your rating never may be that far out of sync. So if you have 1 million ratings for a video and you get an average of 100 a day, that new 100 isn't going to probably substantially affect the rating. So even if you do a batch process, you still might not be that far off. So there's lots of different ways. It would really just be dependent upon your requirements. If you had just a few ratings per video, then just calculate it on the fly is perfectly fine. When you have lots of traffic, lots of clients requesting things, lots of things changing, then you want to start thinking about things like Sharded Counters, or basically using batch processes to update once a day, things like that. Okay. All right. Well, if there's no more questions, we'll go ahead and wrap up this virtual office hours, but it's been fantastic having you in this MOOC. We really appreciate all of the feedback that has been provided on the forums, and we hope that many of you will be in the capstone. And again, we appreciate the interest and the enthusiasm that we've seen, the creativity and the solutions, and we again really encourage you to participate in the MOOC if you're participate in the capstone if you're eligible. If you didn't take all of the MOOCs in the sequence, definitely do that next year or in the next offering of everything. And the capstone will really be a fantastic experience for those who've gone through all of them. So thank you so much, and we will see you in the capstone.